Hey Geometry 2 students, Miss Craft here. Today we're doing a lesson 11.4, which is triangle similarity. And there are three ways to prove triangles similar, and that's what we're going to look at. The first one is angle-angle triangle similarity theorem, noted with just an AA, or I'm sorry, notated with just an AA. And this says that if two angles in one triangle are congruent, and again, important to know that it's congruent, to two corresponding angles of another triangle, then the triangles are similar. So we're going to look at what that looks like, and then how to apply that so that we can prove it. First one here, we're going to use base angles theorem. So I tried to put a little note here of why I know this is true. If my sides are congruent, then opposite angles are also congruent. So I know that I know that angle ACB is congruent to triangle ABC. I could have notated that with one arc mark, but I wanted you to be aware that I know that F is congruent to C, so I did two arc marks. Either way is fine. Okay, so angle B is congruent to angle D, that's given, and angle C is congruent to angle F, and that's by the base angles theorem. So that means that triangle ABC is similar to triangle DEF by angle-angle similarity. Okay. Unlike triangle congruence, which you did in Geometry 1, you only need two pieces of information for angle-angle similarity, and that's because we use triangle sum theorem to then prove the third angle. So that's something that doesn't need to be proven anymore. Okay, my next example is far more common on AZ Merit, and that is given parallel lines. Okay, so you have to remember things from Geometry 1, which are basically our angle pair relationships, corresponding angles, alternate interiors, alternate exteriors, and same side interior angles. Okay, these ones here happen to be corresponding. So I have two triangles, triangle ECA and triangle DCB. If you have a hard time identifying the triangles, I would recommend just redrawing them and labeling them so that it's two separate triangles, because a triangle within a triangle I know I struggled with in high school, and so you might have the same issue. Okay, my corresponding angles are angle E and angle D, and I know that corresponding angles are congruent. And then I have another pair of corresponding angles, angle A and angle B. So because I have two pairs of corresponding angles that are congruent, not the same, like in the same position, I know that the triangle BCD is similar to triangle ACE by angle-angle similarity. I wrote this one differently because there are two ways that I will accept your notations. The first one is angle-angle and write out the word similarity. The second one is angle-angle and write the symbol for similarity. Okay? Please don't try to shorten anything else. That's about as short as it gets. And I will let you know when things are acceptable and not acceptable. Okay, the third one here I left blank for you, but I did leave a little note that you're going to use triangle sum theorem to determine if these are congruent, because the information that you're given is not actually enough. And then make sure that you're identifying your corresponding points correctly so that you can write your statement correctly, because again, your corresponding points have to correspond in your statement also, so we're going to look out for that. Okay. Applying angle-angle similarity is basically just using what we learned in lessons 11.2 and 11.3, I believe, and then finding x values or side lengths or whatever based on the fact that we know the triangles are similar. And similarity, again, is just that one triangle was dilated to get to the other one. Okay. The first thing I did here was prove that my triangles are similar, because they have to be similar in order for me to solve. So angle AEB is congruent to angle DEC, this way, and those are vertical angles. So that's the first one I marked because those are the easiest to identify. Then you have parallel line marks here, which means, yay, I have to use my angle pair relationships. These ones, I could use either angles C and B or angles D and A, but they're both congruent by the same reason, and that is I used angle EAB, obviously the ones that are marked, and EDC. They're alternate interior angles. If you extend these lines here, and this is my transversal, those are on opposite sides of the transversal inside my parallel lines, so that's alternate interior angles. Okay, so my similarity statement, and then what I'm actually being asked for, which is solving for x. So what I have here is 5 over 2 has to be equal to x plus 5 over x minus 1. So our segments are proportional, they are not congruent. And then we're going to solve this proportion for x. Again, a fraction bar is just division. The inverse of division is multiplication. So I multiplied each side by x minus 1. This 5 had to be distributed. So I got 5x minus 5 over 2 equal to just the numerator x plus 5. Then I multiplied each side by 2. And again, you have to distribute. So I have 5x minus 5 equals 2x plus 10. This one worked out nicely for you. Again, I did not show my algebra. I subtracted 2x and then I added 5. That's how I got 3x equals 15. And then divided each side by 3, so x equals 5. Okay, my second example here is a different type of triangle that you will see. So you have seen basically all three possibilities for your in preparation for AZ Merit. This one is a triangle within a triangle, and I have a shared angle here. Okay, so instead of using two corresponding angles, which I could have, I identified that angle A, so angle EAB in my little triangle, is congruent to angle DAC in the larger triangle. And that's because it's a shared angle. So anytime they have the same angle, those angles are obviously congruent because it's the same angle. Okay, and then angle AEB is congruent to angle ADC, and that's because those are corresponding angles. So I know the triangles are similar by angle-angle similarity. Then, instead of being asked to just solve for x, I asked you to find the length of AC. So I first have to solve for x. Again, I'm not going to walk through this. It's basic algebra. And then I have to plug in. So I did get a fraction here, which is why I chose to show you this one also. Because I want you to understand how to add and subtract fractions. You do have to know them. That's not necessarily what I'm assessing you on, but should you get fractions on AZ Merit or my quizzes and exams, I want to make sure you know how to do them. So I have 8 over 5 plus 2, because that's what I'm plugging in for, 8 over 5 plus 2, and then plus 6. What I did was change each of these whole numbers into fractions with the same denominator. So multiplying 2 over 1 by 5 over 5, because I need it over 5, gives me 10 over 5. And multiplying 6 over 1 times 5 over 5 gives me 30 over 5. You can always check by reducing these and making sure that it ends up being these whole numbers. So then I just add my numerators, 8 plus 10 plus 30, and I get 48. And the denominator stays the same. And that's why you look for a common denominator. So the length of AC is 48 over 5. Again, please leave things as improper fractions. Do not turn them into mixed numbers, and do not turn them into decimals. Okay, so that's angle, angle. Then we get to our similarity postulates and theorems that use sides. So we have two of them, side, side, side triangle similarity and side, angle, side triangle similarity. It is really important that you understand that side, angle, side has to use their included angle. It can't just be any random angle on two sides. Just like with congruence, the order matters, so make sure you're looking out for that. So proving triangles similar, I did one example of each here. So this one obviously is going to be using side, side, side because that's all I'm given. I'm given 3 sides, so I need to make sure that all 3 sides are proportional. Again, just checking 2 of them is not enough. So what I'm looking for here is what I wrote down here in this example. Longest side over longest side equal to the shortest side over the shortest side equal to the middle side over the middle side, or your third side that's left. So that's what I did on this one. DE is my longest side, AC is my longest side, so on and so forth. That's how I got this ratio. And then I just set up the ratio. What I first did, because mixed numbers are ugly, I turned 8 1/3 into 25 over 3. So turn it into an improper fraction. Math is much easier with improper fractions. So I have 25 over 3 has to be equal to 21 over 7, which has to be equal to 9 over 3. Same thing from lesson 11.3, I believe, maybe 11.2. When you are trying to reduce complex fractions, you just multiply by the reciprocal or the inverse, as I prefer, of the denominator. So I'm going to multiply by 3 over 25 and multiply by 3 over 25 here. This is now 25 over 1 times 3 over 25. So I get 75 over 25, which is 3. Then 21 divided by 7 is 3, and 9 divided by 3 is 3. Because all 3 of these ratios are the same, I know that the triangles are similar by side, side, side similarity. Okay, the next example is using side angle side. And I know that I'm using side angle side because I'm only given two corresponding sides, but I have tick marks here which tell me that my sides are congruent. So again, I noted that angle CFD is congruent to angle BEA by the base angles theorem. So requires you to remember a lot from Geometry 1. If you need refreshers, please log into HMH and look at the first 3 modules. Okay, then I set up my ratio, and these ratios have to be equal. Set up my proportion. The ratios have to be equal. So I get 15 over 20 equal to 9 over 12. I notated where those segments come from. And I get 3/4 equal to 3/4. So because my included angle, the angle between the two sides that are given, is congruent, or the included angles are congruent, and my sides are proportional, I can say that the triangles are similar by side angle side similarity. Okay, the bottom 4 examples here are just you identifying if you can say that they're similar by side angle side or side side side. The first 2 that I did, I apologize, I apparently picked the 2 that are not similar. But what I want to point out, it's probably better anyway, is that this first example, there is not enough information. That does not mean that the triangles are not similar. You just don't have enough information to prove it right now. And that's because I'm not given the included angle. The included angles would be E and I, and I'm given F and J. It has to be the angle between the two sides, so it's just not enough information. Okay, congruent angles must be the included angles. So the next example here, I did it just like I did this example above, identifying the longest side, the shortest side, and the middle sides, and then setting up my ratio as a proportion has to be equal. So I get 12.6 over 42, that gave me 0.3. If you set up your ratios opposite, it doesn't matter, you'll just get whole numbers instead of decimals. 6 over 20, 0.3, and then 10.5 over 30 is 0.35. Because these are not all equal, these triangles are not similar. They don't have a common ratio, so you cannot say that the triangles are similar. Okay, if you would like, I would recommend doing these 2 examples. I would redraw each of these triangles so that you can match up your corresponding sides to determine if they are similar by either side, 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 or side angle side. Okay, again, that's all for 11.4. If you have any questions, please message me through Canvas. Thank you.